Hi! I was doing web development for a while, and one day I thought, what does it take to write a game in Ruby? I know several good reasons to write a game. It teaches you some interesting concepts, different programming algorithms, and I wanted to write one particular game. It's called Xonix, it's very old, and I wanted to write a very particular implementation of that was created for Windows 95. And this game was a little bit different from the original one. It had orange lines moving around and painting back the field. So in general, this particular game is, I think, more challenging than some others because right from the beginning it teaches you quite relatively complex concepts, especially if you never really worked a lot with algorithms. But I also have a pretty personal story with this game because when I was about 18 years old, I actually tried to implement it, and I thought I failed really terribly. And now looking back and actually being able to get original code of the Xonix that was made for Windows 95, and also just remembering what I did way back in the day, I was actually pretty close to implementing it really well. So what are the good things about this particular game and what was my approach? The first thing that this game teaches you is a flood fill algorithm, which is pretty interesting by itself. And games in general, you have to always think in this realm that you have very short time to make any changes. Basically, if you're running a game at 30 frames per second, you have about 17 milliseconds to do everything. So it's not just writing the algorithm, it's also writing the very efficient algorithm. Second algorithm that I really liked is called Bresenham's line. That's something I heard very long time ago and was always curious how it works, and being able to implement it by myself from scratch was very interesting exercise. I also thought to reverse engineer Xonix itself because source code is available. The thing is that you need to have Windows at least 98 at latest probably, and also Microsoft Visual C++ 6.0. So it took me a little while even to get this set up, which was a very interesting process by itself. And then being able to run and compile Xonix in it, I think gave a lot of good advantage of not just reading the code, but also being able to modify the code a little bit and see how game reacts to it. It definitely helped to understand much better how it works. And also it was a very fun exercise by itself. Getting Windows, getting a very old Visual Studio, and running all of that. Other things quite specific to Ruby is there are several gaming libs, so learning them was a quite interesting exercise. And another thing, I wanted to create binary, not just a game that if you have Ruby you can run it. I wanted to create whole binary, so I needed to find a way how you can make that in Ruby. And one step further as not just binary, but also make it like OS X application, so you can run it as any other application, which was actually a challenge on its own. So this whole process was very interesting and challenging from one point, especially coming from many years doing web development and not doing games at least for 10 or probably more years. Other than the very beginning of my learning of programming languages when I was probably between like 18 years old, that was the only time I was thinking about games. And all the rest of the time I spent in quite different sub-industries of software engineering. I don't want to go too much into gaming libraries because there are lots of tutorials already created. The one I decided to use called Gosu. I'll just quickly get through how did I get it set up. And to create binary from the Ruby script, I used Ruby Packer. Other than learning libraries themselves, there are a couple of interesting things that I decided to read about theory around the games. And that is a pretty good thing to do in general because there are lots of very interesting concepts. For example, there's concept of tick, because you have to do everything in a game within a particular time frame. Managing this time frame that you're using to get all the updates for the game and all the drawing is pretty tricky process by itself. That's why I immediately thought I need some kind of gaming library to at least handle part of these problems. So that's why it's good to use something like Gosu, because it by default gives you a framework where you put all your code and it handles all these like drawing and updates on its own, which is very convenient. Another thing I learned about games is how you can optimize algorithm. Maybe you know something about geometry and maybe you know some formulas, but sometimes these formulas are quite challenging. For example, like how you calculate distance between 2 points. And in a game, you can actually simplify. Instead of squaring things and making square roots, you can just make much simpler additions and substitutions. Also, along the way, I read some stuff about 3D engines and 3D games and how they work, which was pretty interesting thing on its own. First, let's take a look at the game itself. As I said, I was able to do it as Xonix app, which was a pretty cool thing to do. So that's how the game works. The first level is pretty much identical to the original game that was created for DOS. The second one and further levels, you start to have this yellow line that paints back parts of the field. So these white dots, they bounce inside the field and you should not run into them because you lose life. Neither you should run into the black dot. So the goal is to cut out most of the field, and you also have time limit. The faster you do it, the more points you get. Pretty simple and really fun to play with. All right, let's get to the code. The first thing I tend to start with is to do the most challenging pieces, because everything else is going to be pretty easy. So just let's walk a little bit with what I had to start with. First of all, the Gosu, it gives you the framework. You inherit your class from Gosu window, and it has 3 main methods: initialize, update, and draw. Draw has everything to do with obviously drawing on a screen. Update has everything to do with the backend pieces of your game, and initialize is like any other constructor in Ruby. So the first thing that I wanted to learn and was challenging for me, it's called flood field algorithm. Yeah, there are actually multiple of them. So I implemented 3 different versions, and for each version I measured when it works, how fast it works, worst case and best case. So the most straightforward way to implement it was 121 millisecond worse. But when you deal with 30 frames per second, it's too long. My first attempt, called scanline variation, where instead of queuing all the points around current point, you scan the whole line, hence the name. It was 75 milliseconds and it was not fast enough. And the fastest one was combination with scanline and direction check, which means the way I queue the points is in line and in a particular direction. So this way it was 51 milliseconds worse, which was not that terrible. So the main point of this algorithm is to check every field, because every time I cut out the field, I want to know what piece I cut out and what piece I didn't. You can go read about this algorithm by itself. I don't want to go too much into it because it's going to take a lot of time. But basically figuring this out took me several days, and I landed on this algorithm. And the second most challenging thing was so-called Bresenham's line. Alright, so I even put a comment for myself about how exactly it works, because basically it replaces a lot of complex divisions with additions and substitutions, which is pretty cool. So Basically, my benchmark showed it works in under 100 milliseconds, and it's used when this yellow line moves through the field and paints back the field. So it basically, the way it paints the field, it have to basically paint black line on a field, on the virtual field, not even visual field. Visual field handled separately. So the algorithm is looks very confusing. Basically, the core of it is looks pretty simple, but it's very hard to understand what it does. So it's good to just draw it on a paper and see how it works. But after that, everything is pretty straightforward. And I also, instead of just making one thin line, I make it pretty fat. So I add pixels around the pixel I draw. And everything else pretty much came down to handling the gameplay, which was very straightforward. So several pieces that are very important for this game is first is object collision. So basically when I collide with white dots or black dots, or white dots collide with my red line that's drawing the field. So for white dots running into the red line, the function called interference, and it's pretty easy. I just read a pixel under the white line and see if it's red. That is simple as that. And then the second ability, and then the second option for interference is between player and the dots. So I use simplified algorithm here. I just calculate the distance between x coordinate and y coordinate, and if it's less than particular value, I decide that there is collision. It's not super precise, but for the game and for the speed, it's actually a much better way than making precise calculations in this case. So after that, it's pretty much all came down to gameplay, which was pretty unexpected the way I had to go about it, because you can, for example, pause the game, there's next level, and I want to make a little pause between the level ended so you can see your score and situation and between before the next level starts. So actually handling those pauses was another challenge that I didn't expect. Let me show you how it's done. Originally, I wanted to do everything in initialize. But the reality is you have to initialize a lot of objects every new level. So a lot of functions were moved to the next level method. So I update score, reset position of everything. I check if level is the last level, then I show congratulations and high score. If not, I increase the level, I set the time limit properly. I create new field, and I generate all the dots and lines. And then I show the message. So because the backend part and drawing separated, I kind of have variables that tell the drawing cycle of what to draw. For example, I say show ready, and then during drawing cycle or update cycle, I know that I'm in show ready mode. Then I sleep for a couple of seconds so the actual player can see the field. And another example is when I draw, in the draw cycle, if there's show ready, there's a message I put on the screen itself. And I do it for several other situations. When it's time to say congratulations, I put a message, and if it's time to show score as well. The drawing part is pretty straightforward. I implemented objects for every object in the game, field, player, white dots, and all they do is they call draw method on themselves. So majority implementations are in the objects. The update part is a little bit more tricky because that's where I handle all these show and pause messages. And after that, after all these messages, and I also calculate time remaining, because it's important to show in status bar, and also it's important for the points. And then I update player, where it runs flat fill, when it calculates amount of the field that was cut out, and then I update the objects themselves. The only special logic is for interference. So if interference happens, I have to reduce number of lives and pretty much reset positions and some other variables. And then I just handle where the player moves. So the majority of logic is implemented in individual objects. So to quickly give you an idea how it's done. First of all, I have objects for everything that I couldn't categorize and put in any other category, like a player, a dot, or field. So I call it game defs. It defines different Z layers, like how everything above everything else. Even though you look at 2D, there's still, you should understand how objects going to overlap. I also defined colors for backend because I have virtual field and memory, and the way I handle colors there can be much simpler than it's handled actually in the UI. So there are these all the definitions, how many objects should be on different levels, how time limit calculated for different level, how bonus calculated. And actually for all of that, instead of going through each level and verify it every time I make a change, I wrote a test. So it's pretty good to run basic unit tests for a game. So here I test a lot of functions of the game defs object or class, and I verify that whatever this method returns is the value I expect, which actually simplified a lot of work in that regard. I had to do much less manual testing. Now I have class dot. It's more global one because I have two kinds of dots, black and white, so I inherit from it. So it has initialize where it defines where its random position, and it defines how it bounces. It bounces based on bounce pix values, which different from white and black dots. So when I update, it just increases direction based on speed, and when I bounce, it mirrors the speed with this minus sign. Okay. It also needs to know what's next pixel to properly read it and bounce. And it also should know also where the borders, because borders, they go outside of the field. So if you try to read what is pixel there, it's not going to be correct. And then I have a white dot that inherits from dot. It basically just defines particular values, like what is the bounce pixel and initial speed. Same thing for the black dot. So having this parent object simplifies a lot of what I do in child objects. And line is pretty much two dots moving independently, and I just draw the line between them. So orange line basically utilizes line dot object to draw it, and it has function cover field, which is pretty much this Bresenham line that I showed before that draws this fat black line on a field and fills it in this way. And then there's draw function that basically calls Gosu methods in order to draw objects. A field is its own thing, its own class and object. And in the beginning, I just fill it out with blue and black pixels. Then I draw it. Drawing is pretty tricky because you really don't want to draw it pixel by pixel. You have virtual field and you want to fill it out really fast. And the fastest way I found it is to fill it line by line. I think there can be even faster ways, but it was fast enough, so I didn't want to deal with it. But putting every single pixel of the real visual field for every pixel of your virtual field is very inefficient way to do it. So line at least improves it to some point. There's flat fill that I went through already. Interference, that's the drawing pieces. And then the player have score, lives. If you died on this level, it changes how bonus is calculated. Movement is pretty straightforward. I just check that it doesn't go outside of the field. And also I catch when it draws red path, and when it's done with the red path, it's a signal for the field to flood fill that part with the blue pixels. and then I have status bar. Actually, that idea of just having a line and doing pretty much as printf text or something similar like it was done in C a long time ago, I took it from the game, original game, and it's actually a pretty convenient way to do it instead of manually calculate how many pixels I want to put between every message in the status bar. So here I just use percentage, which is like printf function in Ruby. So it takes that variable and it puts these variables into these places in the strings, and there are different, I would say, directions how it should do it. So it's a pretty simple and visual way to actually see how your line gonna be looking like end product. And that's pretty much it on the code side. I don't want to dig too much into it. It's available. I just wanted to give a conceptual understanding what it takes to implement game in general, and in particular in Ruby, what situations you usually deal with and what is the good way to approach it, like how to organize things into classes, how to inherit them, objects usually being very convenient for the games. And also I explored those ideas of how to do backend parts like virtual fields, and then you have real field. And Gosu is a very good library in that regard because it makes you to think from that perspective right away. Now I wanted to look a little bit into Ruby Packer because I did run into a problem with it. Basically, what Ruby Packer does is it doesn't use your Ruby and your gems. It uses its own, and that's where the disconnect happened. And a lot of people, when I Googled it, ran into the same issue. So the solution had a couple of very simple but critical pieces. First of all the gems need to be put in gem file, and when you compile it, log file should be bundled with very particular bundler version, the same one that Ruby Packer expects to have. So figuring that piece out was a little tricky, but once you see the output messages from Ruby Packer, you see what bundler it uses in what Ruby version, you can just use the same, and it's the simplest way around that problem. Second was how you actually provide the arguments for Ruby Packer. So the command of Ruby Packer called rubyc, you just provide temporarily directory where it's just going to put some files. You specify the name of the output file. The root is basically where are your Ruby files, the whole like root directory, and then you specify the Ruby file itself which you want to compile. So this root directory is very important because that's where it will be looking for gem file. So with that structure, it was able to compile it successfully, and if you can see, my structure is not very typical because I have Ruby directory here and it's not the top directory of the project. That's done for app in the OSX because there's very particular structure within the OSX apps, and in order to simplify code for myself, I wanted to repeat the structure in my project so I don't have to put something in one folder and then for OSX apps I'll need to move it to another folder. So basically you have directory with executable file, and then at that level you also have directory with resources where you can have your other things like icons and pictures. So that's why it's organized that way. So this way in a code I can immediately look in the resources directory for all the images I need. Another tricky thing with Ruby Packer is that how you define what is current directory. I used pwd like that because the other way, using like __ file, just didn't work with Ruby Packer. It just shows you different directory, which is pretty confusing. But that gave me the actual directory where file executed in right now, and from this directory I go level up into resources. So it works both if you run as Ruby script, if you run it as executable made by RubyPacker, and if you run it as OSX app. Creating OSX app was a challenge on its own. So I found a really cool app called Platypus. What it does, it makes a script, and you make a script, and from this script it can make OSX app. But my app is not a script anymore, it's a binary now. So as a workaround, I created actual shell script that basically runs the executable that is made by RubyPacker. So here's the whole process. I create Ruby program, my whole game in this library with gem file and Xonix97.rb. So I run RubyPacker command that gives me this output file. I take this output file, put it in resources folder, and that script will run that file from resources folder. And this way everything works together. Now there are important steps for Platypus, like what parameters I specify to create the app itself, which a lot of these parameters are pretty critical. But after that, finally everything worked together, and it's just so much satisfaction when you have this working, like legit app like any other app in OSX. That was really good feeling I had when it got to this point, because there were so many obstacles and I tried to create OSX apps in so many different ways and it just didn't work. So finally I got from this path of Ruby script to binary to the app that can run in operation system as any other app, so it looks really legit. All in all, it was a super fun process. That definitely something refreshing, especially coming from many years of doing web development. It was a lot of fun to work with, and a lot of challenges that just I don't come across on a daily basis doing web development. Highly recommend to do this, especially if you're not into games. And it's also a good way to start if you're into games and you know Ruby already. You don't have to switch languages, so you can have fun and create something simple in Ruby itself. All right, have fun with it.